Okay, we'll do a small topic. Small topic means just one type of problem is to check whether the matrix is orthogonal. What is the orthogonal matrix? What is orthogonal matrix? Orthogonal matrix is one whose transpose is its inverse. Right. So we say that orthogonal matrix A is orthogonal if A inverse is equal to A transpose or A dash. And the problems are just to check whether the matrix is orthogonal, right? So the question is like this: show the is A equal to 2 2 1 minus 2 1 2 and 1 minus 2 2 orthogonal. If not, can you convert it to orthogonal? Second, check whether following matrices are orthogonal. It is 1 by root 6, 1 by root 2, 1 by root 3, 2 by root 6, 0 minus 1 by root 3, 1 by root 6 minus 1 by root 2, 1 by root 3. Second, A equal to 1 by 9 minus 8 4 1 1 4 minus 8 4 7 4. Third, 1 by 13 minus 12 minus 5 5 minus 12. So we need to find the transpose of it, and we will always start with A dash, A into A dash is equal to, so you will write it as 2 2 1 minus 2 1 2 1 minus 2 2 into its transpose, so it will be 2 2 1 minus 2 1 2 and 1 minus 2 2. Multiply and check whether you get identity. If you don't get identity but you get a scalar matrix, what is a scalar matrix? It is the one which is a diagonal one having all the elements identical. So if it is a scalar, then you can convert it to orthogonal, right? Otherwise, if it is only diagonal, we can't help. And if product is something else, so there is no option. And here you will have to simply take the transpose, multiply and check whether they are orthogonal or not, right? Karo. In the first case, what is A dash? It is 9 0 0 0 9 0 0 0 9, right? So you will take 1 by 9 outside and it will be 1 0 0 0 1 0 0 0 1. So we say that it is not orthogonal. Can we convert it to orthogonal? Answer is yes. How? How? So what will be? To convert it to orthogonal, what should we do? What will be matrix A? 2 2 1 minus 2 1 2 1 minus 2 2. We should divide by 3. What happens is you will have to take the root of it. Here it is mod square. So to convert it to orthogonal, it should be 1 upon root 9. So you divide by 3. So it becomes 2 by 3, 2 by 3, 1 by 3, minus 2 by 3, 1 by 3, 2 by 3, and 1 by 3 minus 2 by 3, 2 by 3. So only the first problem was a bit different. Otherwise, all these, if you just multiply, you will get identity. All of them are orthogonal. You know how to multiply matrices. You know how to multiply matrices. First row into first column. So it will be 2 into 2, 2 into 2, and 1 into 1. Right? So it will be 9. Next time it is first row, second column. So it is minus 4 plus 2 plus 2. So 0. Then it is 2 minus 4 plus 2, 0. Okay. First row, first column, first row, second column, like that. Take down these problems, you can do them later. One should know how to multiply the matrices. There is nothing much. So till everybody arrives, I have taken a small topic, orthogonal. That's it. Next part is linear transformations. Linear transformations. Now all those mechanical, computer, IT, all these people will require these linear transformations in the subject called computer graphics later, or some subject like computer graphics and CAD for mechanical. Okay, this transformation talks about, we have some XY system, coordinate system, say I call it as x1, x2. It can be extended to third dimension, fourth dimension, and so on. And I can have one more system like this, say y1 y2. This is just for the explanation purpose. Now whatever point I have here, point P, will have some different coordinates with respect to y1 y2, right? So here if it is say a1 b1 are the coordinates, then over here that point P will have coordinates like these. This will be its a2 and this will be its b2. b2 will be negative, and we want, and all the points are to be mapped. So that's why it is called as linear. Linear because the relation will be a single degree relation. What we are required to do is, given something like x1, x2, x3, it has to be mapped to y1, y2, y3, and there has to be some relation, and that relation is going to be the linear one. You can have something like x1 is equal to 4y1 minus 2y2 plus y3. x2 could be y1 plus y2 minus y3, and x3 can be 2y1 minus 3y2 plus 2y3. This is what we call it as linear transformation. Now any point which is given in y1, y2, y3, we can calculate x1, x2, x3. If these coordinates are known, we can come back. Now obviously the other way around also should be possible. It should be possible for us to express y1 in terms of x1, x2, x3, y2 in terms of x2, x3, and y3 in terms of x1, x2, x3. Now this relation, one can always write it as x1, x2, x3 as some matrix A, y1, y2, y3. Can we? We can. And then this, in this case it can be simply 4 minus 2, 1, 1, 1 minus 1, and 2 minus 3, 2, y1, y2, y3. So this is in the form x is equal to ay, where y points can be transformed to x. If we want other way around, we can multiply both sides by inverse. A inverse x equal to A inverse ay, which is nothing but iy, which is nothing but y. And I will have the other transformation, y equal to A inverse x. Got this? These are called as the linear transformations. So we will have to mainly focus on finding the inverse. And then the problem will be, they will give you that the two coordinate systems are bound by so and so matrix, and given a point 1, 2, 2 in y1, y2, y3, find the corresponding point in x1, x2, x3. So if it is 1, 2, 3, then you can simply substitute these values here, you will get this. But if they say that if the point results in 1, 1, 1, then what was the corresponding point in y? Then you will have to come to this, find A inverse, find that relation, and then substitute. Okay, these are called as linear transformations. Now where do we require these? I said that we will be requiring all of these in the computer graphics. See, I have one system xy, and there will be another system capital X, capital Y. Okay, origin remains the same, it is simply rotated by some angle theta. Now any point over here in original system its coordinates in the new system would be these. Okay, it is as good as rotating the point. See, now the concept is like this. Okay, instead of rotating the coordinate system, is it equivalent to rotating the point in opposite direction by theta? This was original system. This is the new system. Point is in the same position. So I am rotating the coordinate axis by theta, positive theta. Instead, what I can do is I can simply say that rotate that point in the opposite direction by minus theta. It will have the same effect. Everybody is agreeing to this. So my problem reduces to either this way or other way. One point is already given over here and it has to be rotated further by angle theta. This is the original point. This is new point P dash. In that case, the coordinate system is going down because I am rotating it in this direction. Now, can I find these coordinates if initially it makes angle of phi? Now, as I am rotating about origin, it has to have the same distance from origin, so radius remains same, r. So what are the original coordinates of that point? Original coordinates of the point P will be simply r cos phi and r sin phi. Very well, because it makes phi. What are coordinates of P dash? R cos of theta plus phi and r sin of theta plus phi. So suppose we take that x dash, which is r. I call these 2 points as x and y. So r cos of theta plus phi. What is cos of theta plus phi? It is r cos theta cos phi minus r sin theta sin phi. Out of that, r cos phi is my x, so it is x cos theta minus y sin theta. Right? And y dash will be r sin of theta plus phi, which will be r sin theta cos phi plus r cos theta sin phi, and r cos phi is again x, so it is x sin theta plus y cos theta. Okay, this is a linear transformation. Now it depends as how you want to write it. Suppose I want to write it as x dash y dash is equal to xy. So first row, first column should give me x. Or we can't multiply it this. Yeah, we can. So what this should be? Cos theta minus sin theta, and it will be sin theta cos theta. And this is a linear transformation. So all the transformations in computer graphics are linear transformations. Got this? Now I can change, if I want to rotate in opposite direction, change theta to minus theta. Cos of minus theta will remain cos theta. Sin of minus theta is minus sin theta. This will change to ये plus हो जाएगा, this will be minus. Got it? So in case they ask you something to write about linear transformations, this will be the best example and the easiest one to explain. Just the formula substitution. So draw a figure like this, and we are going to rotate the point by this. Okay, and if you are drawing this figure, let me change it to so as to match with this. I will call this as theta again, and original system is my x and y, right, and the new system is x dash y dash, so that the rotation is appropriate. Point has to be rotated in opposite direction. Okay, so this figure, this a simple derivation to explain the linear transformation. Okay, make a note, and then we will proceed to the problems. Problems are as simple as I have shown you earlier. It is x is equal to ay or y is equal to ax given to you. Given one point, you will have to map it to other, right? Actually, in computer graphics, we have got several transformations, right from scaling, rotation, translation, shearing and whatnot, and all those transformations are carried out only through the matrices. So computer mechanical people, remember that we will require this in the programming form afterwards, right? And we need to write a program to multiply two matrices primarily, so that the transformations are carried out. Now the problem goes like this: given capital Y is equal to 4 minus 5 1, 3 1 minus 2 1 4 1, capital X. Find coordinates x1, x2, x3 corresponding to 295 in capital Y. This is a problem statement. What is the given relation? First of all, it is given as y1 is equal to 4x1 minus 5x2 plus x3. Barabar hai? Or is it other way around? No, it is first row column. y2 will be equal to 3x1 plus x2 minus 2x3, and y3 is equal to x1 plus 4x2 plus x3. So it is given as y is equal to ax, but he has given, we are required to find x corresponding to this y, so we want the inverse transformation. So to find A inverse, obviously A in this case is 4 minus 5 1, 3 1 minus 2, 1 4 1, and so mod A will be 4 into bracket 1 into 1 minus plus 8, so 1 plus 8, minus plus 5 into bracket 3 plus 2 minus 1 into bracket, it will be 12 minus 1. So this is 36 plus how much, 25 minus 11. So how much is it? 50. Yeah, 50. And it is not equal to 0. So obviously inverse can be found out. And then inverse we will find by A inverse equal to 1 upon mod A into adjoint of A. So it will be 1 by 50 into the matrix of cofactors and its transpose. So the first element 1 into 1, so this is 9. Second element is 5 with the sign minus 5. Third element will be 12 minus 1, 11, positive. Fourth element corresponding to this will be minus 5 minus 4 minus 9 with the sign, so plus. Then corresponding to this it will be 4 minus 1, 3 will remain as it is. Corresponding to this it will be 16 plus 5, 21, and with minus sign, so minus 21. Corresponding to this element, it will be 10 minus 1, 9, and it will be 3 1 positive 9. Then corresponding to this, it will be minus 8 minus 3 minus 11, will remain minus 11. 11, it will be plus 11, 3 2 plus 11, and this will be 4 plus 15, 19, and 3 3 19, and its transpose. So A inverse comes out to be 1 by 50 into bracket 999 minus 5 3 11, and 11 minus 21 19, right? And then we can say, therefore x is equal to A inverse y. So substitute A inverse, substitute this point 295, multiply, and you will get x1 x2 x3. Had he been giving us x1 x2 x3, then job would have been simple, just substitute and you will get y, but he will always give it other way around. So now we will require it, all the problems are going to be 3 by 3 or 2 by 2. There won't be a problem of 4 by 4, because finding inverse in that case will be difficult. Got it? Complete it. Tell me the answer. Now it is the inverse should be correct, multiplication should be correct, and you should have the unique values for x1 x2 x3. We have got all the elements over here right, except for mod A. What's the problem with mod A? Mein kuch gadbad hai. 1 second, let me do it again. 4 into bracket, it is 1 plus, so 9 barabar hai, minus minus plus 5 into bracket, it will be 3 plus 2 5, and the last one is 1 into bracket 12 minus 1, it is plus 1 into bracket 11, we subtracted this, no? So it is 36 plus 25 plus 11. How could we take minus 72? Yeah, so this is by 72, but still nothing gets cancelled, right? Sorry, mod A माइनस साइन लिखा कहाँ से यार? Right. Tell me what are x1, x2, x3, and then we will solve 1 or 2 problems more onto it. So it is basically a problem of finding the inverse only, nothing more than that. So second problem, it is given as y equal to 1 minus 2 3, 2 0 minus 3, 1 1 1, x1 x2 x3. Find x1 x2 x3 for 2 3 0 in y. It is exactly the same problem, but the next is different. He says x1 is equal to 3y1 plus 5y2, x2 is equal to minus y1 plus 7y2, y1 is equal to z1 plus 3z2, and y2 is equal to 4z1. Express in matrix form and x in terms of z. First problem is identical, so I won't explain that. Second problem, you can see that he has given something like x is equal to ay. Do you agree? It is given as like that. And he has given y is equal to some bz. Right? He wants us to express x in terms of z. So what we will do, we will simply substitute y. So it becomes a into bz. And so this a into b you calculate, that becomes cz. And you will have to write x1 equal to something something z1 plus something something z2. And x2 equal to. So nothing, just a matrix multiplication of 2 by 2. We don't have to calculate anything, nothing. If we would have asked z in terms of x, so we will have to do this and again find C inverse and express. But right now we don't have to do anything. It is just this job to be done. Right? One of again their favorite question in the question paper. Yep, do these two. There was one more. Okay, do this. I had to search for problems because we have even completed this chapter. So one orthogonal was missing. There is one problem which is missing still is you are given a matrix which contains 3 unknowns A, B, C, and he says that this particular matrix is orthogonal, find ABC. That is one more problem that is missing. Otherwise, we have covered everything, all the types. And so once we complete this, I will give you one problem on each part that we have done, right from echelon form, normal form, finding the rank, one problem on simultaneous equations, one problem on PAQ, that is finding the inverse by PAQ, and one problem on homogeneous equations. Right? So we'll just solve all of them in sequence, one by one, so that our task will be complete, and what remains in matrices is just eigenvalues, eigenvectors, which is the last part. It comes out to be odd one, yeah. 21 by 19 minus 16 by 19 minus 5 by 19. So it stays like that. And the second one, matrix comes out to be 23, 9, 27 minus 3. Yeah. So in this particular class, we never take any test as such, right? So this is also not a test, but we will check whether you have got the answers correctly. So it is only on the matrices from day 1 till today, a set of 5 to 6 problems to be solved, except on this linear and orthogonal. Number 1, find rank by echelon form. Echelon form is just reducing the lower triangle to 0. It is 6, 1, 3, 8, 4, 2, 6 minus 1, 10, 3, 9, 7, and 16, 4, 12, 15. Number 2, it is normal form. and it is 3, 2, 5, 7, 12, 1, 1, 2, 3, 5, 3, 3, 6, 9, 15. Oh, turned out to be simple. While writing only I came to know that this is 3 times. So obviously one row will come out to be 0. We will have to check whether any other row comes out to be 0. Third, find P and Q such that PAQ is normal. And I'm giving a simple problem, 1, 2, 3, 3, 1, 2. Fourth one, solve if consistent. Two x plus 3y plus 4z equal to 11. X plus 5y plus 7z equal to 15. 3x plus 11y plus 13z is equal to 25. X plus y plus z equal to 3, 2x minus y plus 3z equal to 1, 4x plus y plus 5z equal to 2, and 3x minus 2y plus z equal to 4. X plus 3y plus z equal to 0, 2x minus 2y minus 6z equal to 0, and 3x plus y minus 5z equal to 0. Yep. So total 6 problems. Out of that, this is pretty simple. Even these are simple. If this would have been asked for normal, then there is a lot of work. But here it is simple. Just interchange and you will get the things. You will get one row of zeros. Making column zeros is not a big job. Fortunately, this is not in PAQ form, because otherwise it will be 3 by 3 and 5 by 5. This is in PAQ, that is okay, because it is 2 by 2 and 3 by 3. So that is manageable. I have not asked the problem on finding A inverse by using PAQ. That is, you reduce it to normal and A inverse is Q into P, right? And one set of equations is homogeneous, and we are required to solve these, but if consistent. So you will have to check the condition for consistency. These two are to be done by lower triangle equal to 0 and back substitution, checking the rank whether row of A equal to row of AB. Right? Do it. We have half an hour for this, so that